In the previous video, we have seen about the three concepts. First, we have seen about, we can say, the definition of gravitation. Secondly, we have seen the circular motion and centripetal force, which is also called center-seeking force. And thirdly, we have seen about the Kepler's three laws, which are also called as Kepler's three laws of planetary motion. Newton studied these three laws and then formulated a new law, which is called Newton's universal law of gravitation. Let us begin with this, the Newton's universal law of gravitation. See what it states: that in the universe, every object attracts every other objects with the force, and that force is directly proportional to the product of their masses and inversely proportional to their, we can say, square of the distance between them. Let us see how this statement we can put in the mathematical form. Suppose there are the two objects are there, that is A and B. Now here the object A has mass m1, object B has mass m2. Now object A attracts object B, at the same time object B also attracts object A. Now their masses are different. One has mass m1 kg, or we can say m1 kg, and other has m2 kg. Now both are separated by distance r. The distance between their center is r. Now this, we can say that in between these two there is a force of attraction is there. According to Newton's universal law of gravitation, object A attracts object B also attracts object A. Now this force is there, force of attraction is directly proportional to the product of masses. So F is directly proportional to the m1 m2. F is the inversely proportional to the square of the distance between them. On combining these two equations, we get F proportional to m1 m2 upon r square. Now we have to remove the proportional sign. So F equal to G m1 m2 upon r square, where G is called universal law of gravitation. So we have seen about the Newton's universal law of gravitation. So there are two objects are there, A and B, which are separated by distance d. Now I have taken purposely the d here, and their masses are m1 and m2 respectively. So according to Newton's universal law of gravitation, F equal to G m1 m2 upon d square, where capital G, it is called universal gravitational constant. Now let us find the value of G. Before finding the value of G, now see, if suppose now these masses are there, if we increase, if we make the masses double, what happens? The product will also increase. It means the force will increase. If we double the masses, if we increase the masses, the force will increase. If we increase the distance, then we can say that the force will decrease. Suppose you are making the masses double. The force will be double. But if you increase the distance double, then the force will decrease by factor 1 by 4. Now you say, why 1 by 4? Just simply you can put the value here. Suppose if you take the distance 1 meter, you will get here 1 square means 1. If we make it double, if you miss, instead of 1 meter, if you take 2 meter, you have to make it here 2 square. Means we get here 1 upon 4. The mass, now force is there, it is decreased by, we can say, 1 upon 4, which was earlier whatever force was there, now force is decreased by 1 upon 4. Now let us see how to find the value of G. Now see how to find the value of G, this capital G. Now it is, we can say, this mathematically the value of G is measured by Henry Cavendish. Its value is 6.67 into 10 raised to minus 11. It is 6.67 into 10 raised to minus 11 newtons per meter square, and per kilogram square. That is the, we can say that the value of capital G. Now let us see how it forms. See, if suppose we can say these two objects are there, their masses are suppose 1. If suppose we can say that their masses are, suppose you have taken 1 and distance also you have taken 1. So what you get, F equals to G into 1 into 1 upon 1 square. So we get here F equals to G. This we can say the universal constant, this capital G, is equals to the, we can say that the force of gravitation. That is the, we are saying the force of attraction. Now this value is there, it is found by putting the, we can say that these are different values, and this force of gravitation, and it is measured by Henry Cavendish. It is value is 6.67 into 10 raised to minus 11. One more thing I have to make it clear. Now suppose this we can say that the capital G is there, and we found its value is 6.67 into 10 raised to minus 11. It is Newton meter square, not per meter square. It is meter square per kilogram square. Now we have seen that the objects are spherical, so we have taken the distance is capital E. Now you imagine, suppose the objects are not spherical, means they are any other shape like this. Then how can we find, we can say their centers? Now in case of spherical, we have taken the distance between the centers one. Like this we have taken distance one. But in case of the, we can say non-spherical one, suppose we have taken one, we can say that the box one, other is we can say that the another shape one. How to find that? We can say here the capital F. How to apply the, we can say universal law of gravitation. At that time, when you are finding the, we can say that this when you apply this Newton's universal law of gravitation, then here in case of these two objects one, they have the different shapes one, not the spherical one. That time we have to consider, instead of, we can say that when you are finding the distance one, we have to consider the center of mass. We have to consider the center of mass. Now center of mass means we have to, we can say that catch this object one. We have to try we can say catch the object in such a way that at one point the whole mass of the, we can say that object is balanced on. Suppose the stick is there. Now suppose you want to find the center of mass. Means you have to just see that at what point this stick will, we can say that the balance one. At that point we can say that there is a center of the mass. This point is called center of mass, and from this point the other also we can see the same. We have to find the center of mass and their distance is considered. Means when the objects are not spherical, that time we have to see the center of mass, then we have to find the, we can say that the distances in between those center of mass as well. Like this we can apply the force of gravitation on the objects which are not spherical. Let us see now new concept, that is the uniform circular motion, and also we can say the magnitude of centripetal force. Now see, we have seen about the centripetal force. This force is there, it starts, we can say exerts from the center of the circle one. Consider object is moving in a circle with uniform speed. Object is moving in a circle with uniform speed. Uniform speed means we can say that its speed is constant one. It moves in a circle. At time what happens? There is a force is there acting on that object from the center of circle. Then that force is there which starts from the center of circle. Through this radius it acts on the object. So it is called a centripetal force. This centripetal force is there, it is always equals to, that is mv square upon r. Centripetal force is there, it is always equals to F equal to mv square upon r. Now consider, suppose we can say that a planet is revolving around the sun. Then what happened? This we can say that the motion of the planets around the sun, or we can say that the motion of the satellite around the, we can say, Earth, around the, we can say, planet. That motions are there, that we call as a uniform circular motion. See, when planets are revolving around the sun, that time what happen? They have the, we can say, under the influence of centripetal force of the sun. That force exists from the center of the sun and acts on the planet. So we can say now here, suppose a planet is revolving around the sun, then that motion is a uniform circular motion. Then afterwards, if you find this, we can say speed one. Now you know the speed is equal to, you know the formula, speed is equals to, that is the distance traveled upon time taken. That is the formula of the speed. Now suppose a planet is revolving around the sun, then to complete one revolution, it takes a time t. We have seen that it is also called as the period of revolution. So when it completes one revolution, it takes whatever time, that time is called as a period of revolution. So if you just see, if you find now when it planet moves around the, we can say, sun, it completes the one circle. The distance traveled is, we can say, the circumference of the circle. So we can say here t means 2 pi r. 2 pi r when it comes? It comes when we can say that the planet is revolving around the sun. So it completes the distance, that is the circumference of circle. And circumference of circle is only 2 pi r. And the time taken to complete this distance, that is the capital T. So we can say here the speed is equals to, we can say that here v is equals to 2 pi r upon t. Now this value will put in this equation. Suppose this equation f is equals to mv square upon r, and second speed v is equals to, we can say that the 2 pi r upon t. This value will put in the equation 1. What we get here? F is equals to m upon r into v square. V square means here 2 pi r upon t bracket square. Then afterwards it is m upon r into, it is 4 pi r square upon, we can say that t square. Now next what we'll do now, we'll multiply both numerator and denominator by r. This is what we get here, m upon r into 4 upon pi r square upon t square into r upon r. See, why we are done like this one, we shall go afterwards. So equals to what we get here, m upon r square into t square, and like that separately t square here, then 4 pi here r cube. So what I got here now, I will write the equation again here. The f is equals to, I will just say now, m into 4 pi, that is 4 pi m upon r square into, I will write here, r cube upon t square. This is equation suppose 3. Now we have seen the Kepler's third law of planetary motion. It is what it says, that is t square upon r cube equals to constant. If you take the inverse, that is the r cube upon t square, you get 1 upon k. Now this value we will put here. This r cube upon t square means 1 upon k. So what we get here? We get here f equals to 4 pi m upon, what we get here now? Instead of this I will get here k into 1 upon r square. Now see, I arrange this equation one, 4 pi m. Now instead of this r cube upon t square, value is 1 upon k. Here I write 1 upon k, and in r square I wrote the separately. So now see, 4 is a number which is constant one. Value of pi is also number constant one. n is the mass of the, we can say that object, also constant one, k is also constant, so it means that 4 pi m upon k, this value is constant one. So we can say that this force is there, it is inversely proportional to the square of the radius, because r means what, r is the radius of the, we can say that the circle one. So this force is there, it is inversely proportional to the square of radius. So see, if suppose the planet is revolving around the sun, that time what happens, that this, suppose the radius, that radius is r, then that force is there, the centripetal force is there, it is inversely proportional to the square of the radius of that, we can say that the planet and the sun. Now let us see the new point. Now it is earth gravitational force. If you see, if suppose if you throw the any object vertically upward, what happen here, after attaining the certain distance, that object starts coming down, then it falls towards the, we can say that the center of earth. It means that here, whenever any object is, we can say, thrown vertically upwards, it comes down and it falls toward the center of earth. It happens because of the, we can say that the gravitational force of the earth. As the mass of the earth is concentrated at the center, we can say that the center of mass is the mass of the earth. The mass of the earth is at the center of the earth. That's why what happens, the object falls towards the center of earth. Now the question arises like this. We have seen in the starting one that the apple falls on the ground toward the center of earth. Then it means that according to the Newton's universal law of gravitation, every object attracts every other objects. Means when the earth attracts the apple, then apple also attracts the earth. Then why don't we can say that the earth, we could not see the earth move towards the apple. Similar way, when we can say planets are revolving around the earth, how this apple falls toward the center of earth, why not the planet falls toward the center of earth? The question is that as we are applying the universal law of gravitation, they are, we can say, applying force on each other. Now the same force is there, but here what happened, because of this, we can say that here the mass, it also, the mass of the apple is very less, so it could not experience the movement of earth toward the, we can say that the apple one. At the same time, what happened here, the when object is, we can say that the falls on the earth and moon does not fall, it means that the, we can say that the moon, or we can say other planets are there, they are in the